So AI agents are absolutely everywhere right now. It feels like you can't go a day without hearing about them. But what's actually under the hood? What's the real engineering stack that makes them tick? Well, in this explainer, we're going to skip the hype and get right into what it takes to build a truly powerful AI agent from the ground up.
And that really is the million-dollar question, isn't it? How do we make that leap from a simple chatbot that just answers questions to an AI that can actually reason, plan, and take action all on its own? We're about to break that down piece by piece.
Okay, so first, let's just set the stage here. Building a true AI agent is a massive, massive jump from what we think of as a basic chatbot. It's a really complex engineering puzzle that involves orchestrating different tools, retrieving data on the fly, and performing some seriously sophisticated multi-step reasoning.
This right here is the core idea we have to get our heads around, the agentic workflow. It's not just about a simple question and answer. Think of the LLM as the brain of the operation. It's the conductor of an orchestra, autonomously using tools, digging up data, and thinking through steps to get a complex job done.
So how in the world do you manage all that complexity? Well, that brings us to the very first layer of our tech stack, the application frameworks. These are what give an agent's logic its structure. And we're going to look at the two biggest names in the game right now.
At a high level, you can think of this as a choice between a specialist and a generalist. Llama Index is the specialist. It's absolutely brilliant at something called Retrieval Augmented Generation, or RAG. Basically, it's designed to retrieve specific facts from your documents to generate way smarter, more accurate answers. LangChain, on the other hand, is like a massive Swiss Army knife. It's a giant toolbox for building agents that can do just about anything you can imagine.
And when you dig in, you can see they have two totally different philosophies. Llama Index uses this event-driven model, which is great for asynchronous tasks. But LangChain, especially with its new LangGraph feature, uses what's called a stateful graph. Now, this is a huge deal because it lets the agent create loops and even correct itself, which is absolutely critical for complex behaviors. Another big difference? Look at observability. LangChain has its very own platform, Langsmith, to watch what's happening, while Llama Index plugs into other third-party tools.
So here's the bottom line. It all comes down to your core need. If your agent's main job is to be an expert on your specific data, like a Q&A system for internal documents, then Llama Index is probably your best bet. But if you need an agent that acts more like a digital assistant, juggling a bunch of different tools and APIs to get a job done, then you're going to want the power and flexibility of LangChain.
All right, so we've got the frameworks covered. But how do the actual models underneath all this understand context so well? How do they connect ideas that are pages apart in a long document? Well, that brings us to the real magic of modern AI, the attention mechanism. This quote just nails it, doesn't it? Before attention, you could think of AI models as trying to read with a tiny little flashlight. They could see the word right in front of them, but they quickly lose the plot. Attention is like a giant, powerful spotlight that sweeps across the entire text at once, lighting up all the hidden connections between words, no matter how far apart they are. So let's break that down real quick. For every single word in a sentence, the model creates what it calls a query. You can think of it as the word asking a question about itself, like, hey, what other words here are important to my meaning? Then it compares that query to a key from every other word. When it finds a strong match, it pulls the value, the actual substance or meaning, from that other word. And this happens in parallel for every single word at the same time. It's pretty incredible.
And the result of all this is, well, it's completely transformative. It solved this huge problem that older models, like RNNs, used to have, where they'd literally forget the beginning of a long sentence by the time they got to the end. With attention, the model can instantly link a pronoun at the end of a paragraph back to the person it refers to at the beginning. This is the absolute foundation of how modern LLMs understand language.
Okay, you've picked a great framework. Your model is powered by the magic of attention. You've built your agent. Now for the really hard part, running it for thousands, maybe millions, of users without going completely broke. This is the production hurdle. LLM inference at scale.
Yeah, in a real-world production environment, a simple little code loop just is not going to cut it. Serving an LLM is a complex systems problem. The inference stack you choose is a huge decision that directly impacts how fast your agent responds and, maybe most importantly, how much it's going to cost you.
So here are the 4 heavyweights in the ring right now. You've got VLLM, which has become the open source standard. It uses a clever trick called paged attention to pack way more user requests onto a single GPU. Then there's Tensor RTLLM. That's NVIDIA's own engine, designed to squeeze every last drop of performance out of their hardware. Hugging Face's TGI is a specialist for those long-context RAG applications, and LM Deploy is fantastic for running those compressed or quantized models on more affordable GPUs.
And just look at these performance gains. They're staggering. A 13 times speed up on long prompts for RAG. That's not just an improvement, that's a total game changer. These aren't minor tweaks we're talking about. Picking the right engine for your specific job is a massive optimization that's going to have a huge impact on your bottom line.
And just to put this into perspective, NVIDIA's Tensor RT LLM, running on one of their top-tier H100 GPUs, can generate over 10,000 tokens per second. That is a mind-blowing level of performance, and it just shows you what's possible when the software is perfectly tuned for the hardware it's running on.
So we have our frameworks, we have the attention mechanism, and we have these lightning-fast inference engines. Those are the powerful components. But getting them all to work reliably, securely, and cost-effectively inside a big organization, that's a whole other challenge, which is why we need to zoom out and look at the full enterprise AI platform.
You see, an enterprise platform isn't just one tool, it's a whole system. It's got to combine the frameworks and engines we've talked about with robust MLOps, that's machine learning operations, to manage the models. It needs a multi-cloud strategy to avoid getting locked into one vendor. And it has to wrap everything in critical layers of data security and governance to meet all those compliance standards.
This quote really captures the shift in thinking you have to make. At the enterprise level, the goal isn't just to get the code to work. The real goal is to deliver actual business value. Success isn't measured by system uptime. It's measured by your return on investment and how fast you can roll out new models that solve real-world problems.
Okay, we have covered a lot of ground here, from these high-level frameworks all the way down to hardware optimization and big-picture enterprise strategy. And that probably leaves you with one really big question. With all these choices, where on earth do you even begin?
And the answer really is to always start with your specific problem. First, figure out the right framework for what your agent primarily needs to do. Is it data-intensive work? Go with Llama Index. Is it complex tool use? Go with LangChain. Once you've made that decision, then you can pick an inference engine that's optimized for the kind of traffic you expect to see in production. It's a simple two-step decision.
So there you have it. You have the blueprint for the modern AI agent stack, from the application layer all the way down to the bare metal. The only question left is, what world-changing agent are you going to build? Thanks so much for tuning in.